This is Math 8, Section 1.6, Real World Problems, Squares and Cubes. I just started the video and I marked something wrong, so I'm just fixing that for us right now. Okay, let's start from the beginning. Evaluate square roots of positive real numbers. We're evaluating things such as 3 squared equals 9, negative 3 squared also equals 9. You guys have learned this and we know it, but we're going to be talking about kind of the signs that we're using here. So 9 is the square of negative 3 because negative 3 times itself, negative 3 equals 9. If we are going this way, 9 is the square of 3. It goes this way too. But negative 3 is the negative square root of 9. And 3 here is the positive square root of 9. So how do we know what the square root of 9 is? Is it 3 or is it negative 3? And this is how we're going to find out. There are two ways you can write it. We could say, what is the positive square root of 9? And to write this one, you could write square root of 9 equals 3. That's the positive square root of 9. But we could also say the square root of 9, the negative square root of 9, is negative 3. So this has two potential answers. So not every number has a square root. For example, negative 9 does not have a square root. This is not a possible problem. We'll learn about imaginary numbers in the future, that's what that is, but there's no square root to it. Okay, it's not a real number. So it has no square root because there are no two identical factors. Because negative 3 squared, that's not going to equal negative 9. 3 squared, well, that's not going to equal negative 9. So we have no options. We can't mix negative 3 and 3 to square them. It just doesn't work. And so there's no square root of negative 9. Let's try an example. Example 24. It says, find the square roots of 49. So the square root of 49 equals, let's find the positive square root, it equals 7. And the negative square root of 49 is negative 7. Pretty simple. So you just have to write positive square root, negative square root. And I would like for you to include this in your answer, even if you shorten it to negative square root and positive square root. These are just shorter ways to write it, but I want you to include that in your answer so that I know what you're talking about. Okay? Try guided practice 1. Here we go. So we have moved on from this top part where we learned that there are in fact two answers. We've been just doing the positive square root, but there are in fact two answers, the positive square root and the negative square root. And it's going to be, well, we're going to go on to what happens with cube roots in real life. Let's evaluate. So we will start with 4 cubed equals 4 times 4 times 4 equals 64, right? Here you go. Well, we can't have a negative number to make a cube. Why? Because if we did, our number would end up being negative here. So all we can say is that 4 is the cube root of 64. And 64 is the cube of 4. To make a table of cubes here, like you see in your book, You don't have to write this whole thing out either because I'm not. But you can see that for x and x cubed, we get 1, 1, 1. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and on and on and on. So for example, the cube root of 64, we just go backwards, it becomes 4, because 4 times 4 times 4 equals 64. So 4 is the cube root of 64. But notice, negative 4 will not work, because negative 4 cubed equals negative 4 times negative 4 times negative 4, which equals negative 64. So between negative 64, you would only have, in the cube root of negative 64, you would only have negative 4. And in the cube root of positive 64, you would only have 4. So cube roots are different because you have an odd number here. Square roots, we have an even number because it's the power of 2. Cube roots, you have the power of 3, an odd number, so your signs have to be the same. We don't have two answers for just one thing. Let's try an example. Find the cube root of 343. To do that, we put it inside these little brackets with a 3 because we're cubing it. We're finding the cube root of it. So you could also write it as inside 7 cubed is the same as 343. We just replaced it. So now, since this matches this, we can eliminate it to just equal 7. Try guided practice 2. Moving on, let's solve equations involving squares and cubes of variables. To solve equations like x squared equals 25 and y cubed equals 125, we're going to have to do some more math because we know already x squared is 25, but what do we know what x is? No. And there's a way to find that. I'll show you with an example. Here is our example, 26. So for A, if we want to find out what x is, we know x squared is 4.41. What we can do is we can figure out how to make this side also be squared just like this side is. So we need to figure out what two things multiplied times each other equals 4.41. To do that, I'm just going to make a little extra spot up here. If we put in our calculator 4.41, it's going to tell us the square root of 4.41 is 2.1. Notice that is the positive square root. We could also have the negative square root. So we have two options here. But we know that this times itself, so that squared is going to equal 4.41. Or negative 2.1 squared is also going to equal 4.41. We know that either of these things could be that. So now that both sides, let me rewrite it, x squared equals 2.1 squared. I'm just going to go with the positive square root for now. They're both squared, so we could take away the square root of each to find that x equals 2.1. In the same way, x squared equals negative 2.1 squared. X could equal negative 2.1 because we got rid of the squareds. So in every answer, in real life, you're going to get two answers because you don't know if it's positive square root or negative square root. So I need to see both answers. Remember, positive square root, negative square root. You need to write these. Okay, next. B. For B, we have x cubed equals 1,000. So, to find the answer, we're going to figure out what the cube root of 1,000 is. To figure out what we need to take times itself 3 times to get this to be to the power of 3. We know that this equals 10. So we could say that this is equivalent to 10 cubed. Okay? Because this is equivalent, this is equivalent. 10 cubed equals 1,000. So we know this can't be negative because then that would equal negative 1,000. So we only have one option here for cube roots. We are going to convert that. X3 equals 10 to the power of 3. X cubed equals 10 cubed. So we could say that x itself is just equal to 10. Just like up here. This was our full answer. For cubed, you only have the one answer. Go ahead and try this on guided practice 3 and 4. Okay, next problem. We're going to actually solve some real world problems here, hopefully. Solve, real world problems involving squares and cubes. Here we go. Let's look at the equation in the book here. You can use equations that involve squares and cubes to solve real-world problems. Sometimes only one of the square root solutions makes sense for the problem. For example, suppose an artist wants to make a cube-shaped sculpture. The area of the sculpture is 144 inches squared, the area of one side, right? And the volume of the whole sculpture is 1,728 inches. The volume of the sculpture is in cubic inches. To find the length of the edge of the sculpture, so say they want to make something with this big of an area, we're going to have to solve it using either of these equations to get the cube root. By the way, that's why it's called cube. Because if you have cube and you want to find one side, you use the cube root, because 1 times 1 times 1. So to find the square root, you just have a simple square, and that's why you square it, because it's just this side times that side. So we can use either one to figure out what the length of one side is. The first equation is going to have a positive and negative solution. If x squared equals 144, and we know that 144 is, and we know that here the square root of 144 would be equal to 12 squared. So x is going to be equal to 12 inches. Or the negative square root, x could be equal to negative 12 inches. Well, we know a length of the side of a cube can't be negative. So we could eliminate that and we could figure out that the side needs to be 12 inches. So in the real world, you might have two solutions, but one of them would only work. So there's cases where a negative would work for an answer if it's going to be on the negative side of a number line. But if you know that it's the side of a square, you know that it has to be positive, and so you could eliminate the other answer. Let's try this in an example. Teresa wants to put a piece of carpet on the floor of her living room. The floor has a square with an area of 182.25. When it says square inches, you write inches squared because it's been taken an inch by an inch. Oh, it's feet, sorry, not inches, feet. So how long should the piece of carpet be on each side? To do this, we want to find x. We know that x squared equals 182.25 feet squared. So let's figure out what x is. We can take the square root of both sides. The square root of x squared is x, and the square root of this, put it in your calculator, is 13.5 feet. Remember that we get rid of the squared feet here because we've taken the square root, so it's just feet, and x equals 13.5 feet. And that's the length of one side of the carpet. Okay, go ahead and try guided practice with this. 5. Moving on, example 28. We're going to solve another real world problem using cubes though. Last time we used squares. So a fully inflated beach ball contains 288 pi cubic inches of air. When it's cubic inches, it's inches cubed, and so you write it like this. What is the radius of the beach ball? So radius is our question. What are we trying to find? Now, the book gives you the formula for volume of a sphere. It's also in the back of your book when it gives you the formulas. And this formula is volume equals 4/3 pi r cubed. We know volume, right? This is volume. So volume could be substituted in this equation. So let's carry this equation down, put volume, substitute in, inches cubed. So we put that in for volume. It's equal to 4/3 pi r cubed. Now we got to do a little bit of algebra here to simplify. We're going to multiply both sides by 4/3. Or, I'm sorry, we're going to multiply both sides by 3/4 so that 4's cancel, 3's cancel. 3/4, which leaves us with 216 pi inches cubed, because we took 288 times 3 and then took that divided by 4. Over here, the 3's canceled, the 4's canceled, that leaves us with pi r cubed. Now we can divide each side by pi. Over here it cancels. If we divide it by pi here, those cancel. That leaves us with 216 inches cubed equals r cubed. Now you just have to find the cube root of each side. The cube root of r cubed is just r, and the cube root of 216 inches, not 2.16, sorry, it should just be 2.16. The cube root of that is 6 inches. So the radius of the ball is going to be 6 inches. Alright, using the approximate value of pi, you could have found something out here, but our pi is canceled, so we didn't even have to enter that into the calculator. Now go ahead and try guided practice 6 and 7.